Okay, good day everyone. I hope everybody is well this day and I believe that you're gonna enjoy my lessons. I go by the name of Tsepo Maifo. Today I'm going to do Euclidean geometry. This is for people who are doing pure maths and technical maths. So it's for people who are doing again grade 11 and 12. So some people find it difficult when it comes to this topic, which is Euclidean geometry. But before we go further, before we go into theorems, here's something that we need to understand about the circle. So when we refer to the circle, remember a circle can never be a circle if there is no center between it. So remember, from a center of a circle to the circumference, remember this is a circumference. Isn't it? And then here, from a center of a circle to the circumference, this is a radius. And then from this part up to that part, in the center of a circle, this is what we call a sector. And then from this line up to that line, we call it an arc. And then from circumference, a line that passes through the center of the circle to another, this is what we call a diameter. And then remember that this line, the line that touches the circle at one point, this is what we call a tangent. Isn't it? So from this part up to that part, this is a chord. A line that is drawn from between a circumference and this part, that is what we call a chord. And then a space between a chord and the circumference, we call it a segment. Isn't it? So now, before we can go into theorems, remember we were taught in grade 10 that we have parallel lines. Let's say we have A, we have B, we have C, we have D. We were taught about parallel lines, whereby in the parallel lines, you can have fun. Fun means, if you see in a parallel line, this is A, this is B, this is C, this is D, this is E. It means that this angle equals to, let's say C1, this is C2. It means angle A is equals to C2. Reason being, this is corresponding angles. Corresponding angles that was defined by two lines AB being parallel to DC, isn't it? And then we come again, we have U. And then we have parallel lines. Let's say this is D, this is E, this is F, this is G. It is whereby angle G and plus angle F are equals to 180. Why? Because of these are four interior angles. They are defined by D, G being parallel to E, F. These are the basic things that we need to do, that we need to know in maths. And then we have N again. Somebody can say N, somebody can say Z. Let's say this is M, this is L, this is N, this is O. Therefore, because of these two lines, angle L is equals to angle N. Angle L equals to angle N. Reason being, this is an alternating angles, whereby LO is parallel to MN, isn't it? So these are the basic things that we need to know. And then, as we continue, we have theorem 1. Okay? So now we have a circle. We have the center of a circle. And then it tells us, and again we have what we call a chord. According to theorem number 1, this is A, this is B, this is O. It means, let's say this is C. It says a line drawn from the center of the circle is perpendicular to the chord. We said this is a chord. AB is a chord, which means OC is the line drawn from the center. Line drawn from center. And then what do we have? It means that OA and OB are equal. This is a right to prove that OA is equals to OB. Therefore, again, that makes AC, if these two are equal, that makes AC to be equal to CB. AC being equals to CB. This is according to theorem 1. This is what you need to know according to theorem 1. And then theorem 2. When we refer to theorem 2, it says an angle at center is twice an angle at the circumference. This is what we are talking about. Let's say we have a circle. As we have a circle, we have a center of a circle as O. It means what they are telling us, we have about 3 circles that we are going to do according to theorem 2, where it says an angle at the center is twice the one at the circumference. Therefore, you have A, you have B, you have C, isn't it? Because we say this angle is twice that one. It means O, angle O is double of A. That's what they are telling us. And then we have another circle again. As long as the lines touch the circumference, they touch the center of the circle and the circumference. And then we have another one again. Is in this form. This is O, this is B, this is C, this is D. This angle, this is an outer part. This angle is twice the one at the circumference, which means they must have a relationship due to directions. Even this one faces down, so is the other one must face down. Therefore, we have O being equals to, angle O being equals to double of D, isn't it? And then we have again the third one, the third circle. In this third circle, we have a drawing like a butterfly. This is O, this is D, this is E, this is F. It says this angle is twice that one. It means O being equals to double of F. So these are the two theorems for now that I can be able to tell you about. So if is there anyone who has a problem, who has any questions under Euclidean geometry, send the question papers to me and you will meet Tsepo Maivu. Shalom. Oh.